Hello viewers, this is Mahmood. In this video, we are going to solve system of linear equations by using Gaussian elimination method. The system of linear equations is given to us. So the first step in the Gaussian elimination method is that first we need to rewrite the system of linear equations into equivalent matrices form. Okay, so that is the equivalent matrices form would become, the first matrix contains the coefficient matrix. That is, in the first equation, the coefficients of the variables are, 2, -6, -4. So 2 is the coefficient of x, -6 is the coefficient of y, and -4 is the coefficient of z. Similarly, in the second equation, the coefficient of variables are 3, -5, and -17. In a similar way, the third equation has 2, -9, and 5. Okay. Next, we have to multiply with the variable column, that is x, y, and z is equal. The right side would become our constant matrix, that is -6, -72, and then 45. Okay, if you do the multiplication of these two matrices and then equate with the right hand side matrix, so you will get again this system of linear equations. So here this first matrix means the coefficient matrix. We denote this matrix by A, and this variable matrix is denoted by X, and the right hand side matrix means the constant matrix is denoted by B. Okay, now the next step is, we are going to make an augmented matrix A with matrix B. Okay, augmented matrix is a matrix in which we are doing same operation with two matrices. Okay, so here first we are going to write matrix A, that is 2, -6, -4, then 3, -5, -17, and then 2, -9, and then 5 with vertical bar. The constant matrix means the matrix B, that is -6, -72, and then 45. Okay, so first we are going to make the pivot element 1, because the calculation would be easy for that. Okay, so the pivot element means the first non-zero entry of the row is what we call the pivot element of that row. Okay, so here we are going to make this 2 1. How to make it 1? So we just multiply 1/2 with row 1. Okay, so that is going to be, this is my augmented matrix. So we are going to multiply 1/2 with row 1. So when we multiply 1/2 with 2, so that would become 1, -6 would become -3, -4 would become -2, and -6 would become -3. The rest of the elements will remain the same. Is it okay? Now you can see here the new matrix is no more equal to the preceding matrix, the last matrix, because the first row is completely changed. You can see here. So we can't write here the equal sign. Okay, so we can say this matrix, this new matrix, is row equivalent to the last matrix. So symbolically we can write like this way: R is for row, and this tilde symbol is for the equivalent. So we can say this new matrix is row equivalent to the last matrix. Okay, now we are going to convert or reduce this matrix into echelon form. So for the echelon form, we are going to make this 3 and this 2 0. This is row equivalent. We are going to write the first row as it is, that is 1 minus 3 minus 2 and minus 3. So now you can see here, this is 3. So if we multiply 3 with row 1 and then subtract from row 2, so this 3 would become 0. So that is row 2 minus 3 multiplied with row 1. Okay, just like, if we are going to write, row 2 elements like this way, 3 minus 5 minus 17, and just multiply 3 with row 1. The first element is 1, so 3 times 1 is 3. 3 times negative 3 is negative 9, and 3 times negative 2 is negative 6, and similarly 3 times negative 3 is again negative 9, and here also there is negative 72. Now these are basically the entries of row 2, okay, and these are basically the entries of row 1 by the multiple of 3 basically, okay. And now we are going to subtract them, r2 minus 3 times r1, so we need to subtract them just like this, okay. So the first would become 0, the second would become negative 5 plus 9, that would become 4, and here negative 17 plus 6 is going to be negative 11, and here negative 72 plus 9, that would become negative 63. So just write all these elements in the second row. So that is 0, then 4, then negative 11, then negative 63. Is it okay? Yeah. Now next, in the third row, we are going to make this 2 0. Again, do the same process, that is r3 minus 2 times r1. Okay, so that is 2, and we are multiplying 2 with row 1, so 2 minus 2, that is 0. Here minus 9, that is minus 9 minus 2 multiplied with negative 3, so that would become negative 6. So that is negative 9 plus 6, that would become negative 3 here, okay. And then 5, 2 times 2 is 4, so 5 minus minus 4, because there is a negative sign, so 5 minus minus 4 means 5 plus 4, that is 9, okay. And here 45 and 2 times negative 3 is negative 6, 45 negative negative 6, that will become positive 6, so that is 51, okay. Now the next step is, we are going to make this negative 3 0, okay. How to do this one? So that is again row equivalent, and that is the first row would be the same, that is 1 minus 3 minus 2, and then minus 3. And the second row, if we multiply 1 upon 4 with row 2, so that would become 0, 1. First we are going to make this 4 1, okay. The calculation would be easy. So, and this negative 11 would become negative 11 upon 4, and here this would become negative 63 upon 4, and the last row would be the same, that is 0, negative 3, 9 and 51. Is it okay? Now let's move further on. Now we are going to make this negative 3 0. So again, this is row equivalent, the first row is the same, 1 minus 3 minus 2, and then minus 3. The second row is again the same, that is 0 1 minus 11 upon 4, and then minus 63 upon 4. And now we are going to make this negative 3 0. So can we write R3 plus 3 times R2? If we multiply 3 with row 2 and then add with row 3, so this negative 3 would become 0. Okay, so that is 0 here, minus 3, and multiply with row 2 3 multiply with row 2, so that would become minus 3 plus 3, that is again 0, and here 9 plus, you have to multiply 3 with negative 11 upon 4, so that would become 4. 36 minus 33, that would become 3 upon 4. So here 3 upon 4, and the last one is 51. That is the third row element is 51, and then plus 3 times the row 2 element is minus 63 divided by 4. So here we have 4 would be our LCM. So this is going to be 204, and then minus 9 and 18, so 189. So just subtract them, so you will get 15 divided by 4. Okay, that is 15 divided by 4. So now the next step is you have to make this pivot element 1. So again we have to multiply the reciprocal of this element by row 3. Okay, so again this is row equivalent, so the first row would be the same, that is 1 minus 3 minus 2 and minus 3. The second row would be the same, 0 1 minus 11 upon 4 minus 63 upon 4. And now we are going to multiply the reciprocal of 3 upon 4 is 4 upon 3 with row 3. Okay, so multiplying with row 3, so this is 0, this is 0, and when we multiply the reciprocal of 3 upon 4 with 3 upon 4, so that would become 1, and now multiply with 15 upon 4 with 4 upon 3, so that would become 5. So here we get 5. Okay, so now we reduced the matrix, the augmented matrix, into echelon form. You can see this is my pivot element of the first row, this is the pivot element of the second row, and this is the pivot element of the third row. You can see each pivot element is on the right side of their preceding one. You can see here, this is the pivot element of the second row, that is on the right side of their preceding one. Similarly, this pivot element is on the right of their preceding pivot element. You can see 1. And now all the pivot elements are also ones, so it's clearly an echelon form. Okay, now you can see this matrix is basically our matrix A, and this was our matrix B. Now it is updated. Now you can see these are the coefficients. The first column, basically these entries are the coefficient of x, these entries are the coefficient of y, and the last column, this one, these are the coefficients of z. Okay, and after the bar, these entries are basically the entries of the constant matrix. Okay, so if you can see from row 3, can I write only z, 1 times z is equal to 5. So from row 3 we got the value of z, that is 5. Okay, and similarly from row 2 you can see the coefficient of x is 0, the coefficient of y is 1, so that is y minus 11 upon 4 into z is equal to minus 63 upon 4. Okay, and now just putting the value of z here, so that is y minus 11 upon 4 into 5 is equal to minus 63 divided by 4. Okay, just shift this constant on the right side of the equation, so it would become y is equal negative 63 upon 4 plus 55 upon 4. Okay, so here we have just add them, so you will get negative 63 plus 55, that is negative 8 upon 4, and that is nothing but negative 2. So the value of y here is negative 2, right? And the last one, that is the value of x, and that will obtain from the row 1. So from row 1 you can see the coefficient of x is 1, so that is x. The coefficient of y is negative 3, so negative 3y, and the coefficient of z is negative 2. Z is equal to, the right side is negative 3. So putting the values of x and y, okay, so here x minus 3, y is negative 2, so we put negative 2 here, negative 2, and the value of z is 5, so 5 is equal to negative 3, and here x is equal to negative 3 times negative 2 is positive 6, and then minus 2 times 5 is minus 10. So 6 minus 10 is going to be minus 4 is equal to minus 3. Just shift this 4 on the other side. So the value of x is equal minus 3 plus 4, and that is equal plus 1. Okay, so this is the value of x. Okay, so finally our matrix x, that is basically what? That is x, y, and z, and that is equal to, what is my x? That is 1, so that is 1, and y is minus 2, and z was our 5. Okay, so this is basically our solution. Okay, you can also write in a set form, that is order triple, that is 1, negative 2, and 5. This is basically our solution by Gaussian elimination method. Okay,